He has already left. Okay. So recording has started, so we can start now. So I want everybody to pay attention, right? So today we are going to cover the last topic, that is the identification of the eigenvalues and eigenvectors using the Jacobi method, right? So this method is basically very vast. थोड़ा सा calculations whatever involved in this particular method, they are on higher side. So we will be taking a problem of only 2 by 2, but I'll be explaining you the method with the help of a 3 by 3 problem. Okay. So now in this particular method, basically what is happening is like this. So we have a matrix, for example. It can be n by n matrix. Okay, it can be 2 by 2, 3 by 3, 4 by 4, whatever maybe the size. So in this method, we have to convert this. Okay. There is something wrong. Just wait up. Okay. Still. Okay. Fine. Now it is working. Okay. So we have to convert this into a matrix which looks like this. And what we call this matrix? Diagonal matrix. Okay. So all the elements which are there in the upper triangle and lower triangle, they should be eliminated, right? So for example, if it is a 3 by 3 matrix, okay. So if it is a 3 by 3 matrix, then we have to eliminate 3 elements from the upper triangle and 3 elements from the lower triangle. So total 6 operations we have to perform on this particular matrix. Okay. If it is a 2 by 2, then one element in the upper triangle, one element in the lower triangle. So 2 operations we have to perform. Like that, if the size of the matrix increases, the number of operations they will also increase. Now, the best part of this particular method is if you are operating on a symmetric matrix. Okay, what is symmetric matrix? The elements which are there in the upper triangle, the same elements are there in the lower triangles. So if you are trying to eliminate any element which is there in the upper triangle and the matrix is symmetric, so the equivalent element which is there in the lower triangle, it will be also directly eliminated. So your job is completely reduced. Okay, but this process of converting a given matrix into a diagonal matrix, it's very tedious. Okay, it involves lots and lots and lots of calculations. Okay, so basically, for example, if we are dealing with a matrix of size 3 by 3, so you have to perform 6 operations. Okay, so in this particular method, what you will be doing, from A, you will be generating A1. Okay, then you will be generating A2, then you will be generating A3, so on up to you can generate A6. बराबर है? तो ये 6 तुमको बनाने पड़ेंगे, right? So now let us try and understand how you are going to generate A1 from A. Okay, very first step. So basically, we are trying to convert this A into A1. Okay. Now, for this purpose, you need to remember one simple equation, that is A1 equals to P transpose into A into P. Right? So your A is your original matrix. So we have two matrices, one is P transpose and one is P. Or basically only one matrix, one is the transpose and one is the regular matrix. Right? So now, for example, if we have a matrix which is like this is one value, this is one value, all these values are there, these are non-zero values, right? So if you want to convert this particular element, what is the location of this element? First row and second column. Okay, so likewise you have to eliminate the other one, bottom one, and 6 more. So we are operating only on the first element, that is first row and second column. So if you are trying to eliminate that particular thing, is in that case what will be your P matrix? Okay, so you need to understand how this P matrix is generated. P matrix, ideally it is a identity matrix. Okay, so I am writing simple P matrix, right? Now since I am eliminating a term which is over here, that is first row and second column. So if I'm eliminating that, in that case here I need to write down minus sin theta. Okay, तो जिसको हम लोग एलिमिनेट कर रहे हैं वहां पर हमको लिखना है माइनस साइन थीटा. Now remember the location is first row and second column, that is 1 and 2. You reverse that, that is 2 and 1, that is second row and first column. Which is this location? This one. Okay, so in that particular location you have to write down sin theta. Okay, so if you are eliminating 1 and 2, so in location 1 2 you write minus sin theta, you reverse the digit 2 1 you write sin theta. Is it clear to everyone? Right, now there are two numbers 1 and 2, right? One represents row and 2 represents column. So now I am combining both. So I have now two more combination. One is location number 1 1, that is first row first column, and then location number 2 2, that is second row and second column. So in these two locations you have to write down cos theta. Okay, so whatever elements you are eliminating, there you write minus sin theta, change the signs or change the digits, you write plus sin theta, and 1 1 2 2 you will have cos theta cos theta. Have you understood this? Okay, so now you understand that in this particular case, that is in this particular case, what element you are eliminating? This you are eliminating to 0. Barabar? So here you will have a matrix, that is A1 matrix, which will be, here you have P transpose, where this is your P matrix, so iska transpose, this will be your A matrix and this will be your P matrix once again. Okay, so now your P matrix contains a term of sin theta cos theta. P transpose also contains a term sin theta and cos theta. बराबर, A matrix की वैल्यू तुम लोगों के पास ऑलरेडी है. So when you multiply all these things, what you are getting? You are getting a A1 matrix, which is like this. Here you have some terms, here also you have some terms, here also you have few terms. Now all the terms, they will be in terms of sin theta and cos theta with some constants. Agreed? Now what exactly we are doing? We are basically trying to eliminate this equals to 0. बराबर है? So whatever expression is there over here, तो यहाँ पर एक expression आएगा sum 2 cos theta sin theta plus sin square theta plus something कुछ आएगा. Okay, so all that you just have to equate it to 0, because हमको उसको 0 करना है. So once you equate that particular thing equals to 0, so what you will be getting? Theta value. Correct? Once the theta value is known, what you can do is you can substitute the theta value in this particular expression and you can get A1 term. Now in the A1 term, location 1 2 will be 0. Correct? So it involves a lot of calculations, right? Like I said earlier, this is just one step. We have generated A1 from A. Now you have to generate A2. अब A2 कैसे generate करोगे? For generation of A2, so you have A1. Now you will be generating A2, right? Now your A1 looks like this. करेक्ट, जिसमें से ये तुम्हारा 0 है, बराबर. सो नाउ यू हैव टू जनरेट A2. सो योर A2 will be a similar term, that is P transpose into now A1 into P. ठीक है. Just for sake of understanding, what I will do, the earlier P, this P, I am going to call this as P1. Okay, this is P1. Okay, this will be also P1, right? Here I am going to write down this as P2. So now in this particular case, what I am trying to eliminate, I am trying to eliminate this. बराबर है. So if I am trying to eliminate the element which is there in the first row and third column, in that case, what will be my P, or rather I should say P2? It will look like this: 1 0 0 0 1 0 0 0 and 1. This is identity matrix. So like I said earlier, 1 3, this is my 1 3 location. So here I should write minus sin theta. If it is 1 3, then you have to go for 3 1. Where is my 3 1? This is third row and first column. Here what should I write? Sin theta. And then add 1 1 and 3 3. 1 1 and 3 3, what should I write? Cos theta. So this is 1 1 and this is 3 3. Here I should write cos theta. Okay, I hope you understood the concept. So every time you have to do this operation, you generate transformation matrix P. Okay, then your A matrix you multiply, and whatever you do this calculations in the A2, the location 1 3 has to be equated to 0. Okay, and then you get the value of theta. Substitute the value of theta, you will get 8. So big calculations. Okay, likewise, when you keep on going on and on and on and on, what you will find at A6, you will find the given matrix is converted into a diagonal matrix, and all the diagonal elements, they are nothing but your eigenvalues. It's a big task. Okay, now what about the eigenvectors? हम लोगों ने अभी तक आइगन वेक्टर्स नहीं पढ़े. आइगन वेक्टर सिर्फ डायरेक्ट मेथड में पढ़ा हुआ है. ओके, but in this method you can get the eigenvectors also. How? Now you see, you have A matrix, you have A1, A2, A3, A4, A5, A6. In this total process, you have generated P matrix, P1 matrix सबसे पहले बनाया, then P2 matrix, then P3 matrix, up to P6 matrix. So in order to get the eigenvector, you multiply all these P matrices. P1 into P2 into P3 into P4 into P5 into P6. Big task again. But whatever P matrix you will be getting, so the first row of that P matrix will be denoting the eigenvectors of first eigenvalue. The second column of the P matrix will be reflected as the eigenvectors of the second eigenvalue. And third column will be the eigenvectors of the third eigenvalue. Clear? Now, just to understand this, we'll take a simple numerical which you will simply observe. Okay? तुम लोगों को सिर्फ इसको देखना है, लिखना कुछ भी नहीं. Okay? So you see, this is a matrix which is there in front of you. Okay, don't write. This is 2 minus 1 0 minus 1 2 minus 1 and so on. So you can see this is a symmetric matrix. Okay. So now basically what I am trying to do is I am trying to convert this matrix into a diagonal matrix. Okay. So I think 1 is already 0, so my task is reduced. ऐसा लगता है. ठीक है. अब आगे देखो क्या होता है. So we are basically trying to eliminate that minus 1. So minus 1. So I am talking about location 1 and 2. That is first row and second column, right? So accordingly, I have written this P matrix cos theta minus sin theta 0. ये concept समझ में आया? So I am trying to eliminate location number 1 and 2, first row and second column. So I have generated this P matrix. Okay. So my A1 matrix looks like this. That is P transpose into P. Sorry, P transpose into A into B. So I am talking about this equation. अब मैंने क्या किया, मैंने इसको expand किया. Okay, I have done some calculations. So to do the calculations, what I have done, I have first of all taken the multiplication of this, that is P transpose into A. ठीक है, और बाकी का P मैंने वैसे रखा हुआ, right? So I got this, okay. Then I have done the multiplication of that one also, so I got a very big matrix. You can see this. आ गया भाई, आया, बहुत बड़ा मैट्रिक्स आया, ठीक है. नाउ इसके अंदर अननोन क्या है, थीटा. What exactly we are trying to do? We are trying to eliminate the element which is there in location first row and second column. तो इसमें से फर्स्ट रो और सेकंड कॉलम कौन सा है, माइनस 2 टाइम्स साइन थीटा कॉस थीटा प्लस साइन स्क्वायर थीटा माइनस कॉस स्क्वायर थीटा प्लस 2 टाइम्स साइन थीटा कॉस थीटा. ठीक है. So I am going to collect that particular element and I am simply going to equate it to 0. Okay, this is what I have done in the next step. So in that particular step, I have equated that, and then there is only one unknown, that is theta. So I got the value of theta after solving this. The theta value is 45 degrees. So once the value of theta is known, I am going to substitute the value of theta in the highlighted equation which is over here. Okay. So after doing all this calculation, I got a A1 matrix, and that A1 matrix, if you observe, the location number A12 is now 0, right? But since it is a symmetric matrix, A21 location is also automatically becoming 0. Okay. Remember, in A matrix, A13 was not, A13 was 0. That is first row and third column was 0. But after all this operation, that location is destroyed, and now it is a non-zero value. 13. That is first row and third location. Okay. So now you just imagine that this is just one step. So in the second step, now you will have to eliminate the other one. So in this process, we have generated this P1 matrix. Okay, P1 matrix was cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. I have just substituted the value of theta over there, and this is my P1 matrix. Okay, so now this is first step. Now in the second step, I am going for A2. So A2 is a product of P2 transpose into A1 into P2. Barabar? So again, in this particular case, I am trying to eliminate location number first row and third column, A31. So now in this case, what is going to happen? Your P matrix will look like this. Just now we have seen. Okay. So you do the calculations, you substitute the values. Okay. You do the calculations and get the location 31, which is over here. So if I read out, that is minus sin theta cos theta plus 0.7071 sin square theta minus and so on. Okay, equate it to 0. You will be getting the value of theta as 27 point so and so. Then you substitute the values. So your A2 will look like this now. Now in A2 you will find location number 1 and 3 is 0, but 1 and 2 is again non-zero. Don't worry. Nothing is going to happen, but you have to follow the steps. Okay, so we have tried to eliminate 1, 2, then we tried to eliminate 1, 3. Now we'll go for other one also. So like this, you keep on doing again and again, again and again. This is your A5, and lastly, your A6 will look like this. Okay, so in A6, you get 2, 0, 0, 0, 0.586, 0, 0, 0, and 3.41. This is after 6 cycles. Very difficult task. Okay, but I'm just trying to explain you the method. Okay, so this is how you will be getting the eigenvalue. So first eigenvalue will be 2, second eigenvalue will be 0.586, and third eigenvalue will be 3.41. Okay, now coming to the eigenvectors. So like I said, in this entire process, we have generated P1, we have generated P2, P3, P4, P5 up to P6. So all those matrices I am multiplying. So you can see in the top P is a product of P1 into P2 into P3 into P4 into P5 into P6. Okay, So as a result of this, you will find there are 6 matrices, multiplication going on, and at the end you are getting this one. So the first this column. So this column is nothing but the eigenvector of first eigenvalue. Okay. The second column is the eigenvector of the second eigenvalue, and the third column is the eigenvector of the third eigenvalue. Clear? Yes. Pakka? I know it's a lot of calculations, so don't expect a 3 by 3 matrix in the exam. Okay? ये टॉपिक एमटेक में भी है, एमटेक में भी नहीं पूछते 3 by 3 का मैट्रिक्स. Okay? So we'll go with only 2 by 2 matrix, and we'll go with a very simple one. Okay? You don't have to do much, right? So I think I have already one solved problem available with me. So everybody will solve this. Okay, so this is 3 6 and 6 8, right? So let us do this. Okay, I want everybody to do this. So let me draw a straight line, and I have a matrix which is having 3 6 6 and 8. Is it so? Yes. Okay. Now I want everybody to do the calculations also. Okay. Now in this case, what exactly we are trying to do? We are trying to convert a given matrix into a diagonal matrix, right? So when I say diagonal matrix, that 6 has to be gone. Okay. So basically this A has to be converted into A1. Okay. Where A1 would be a product of P1 transpose into A into P, correct? अब उसमें से P क्या होना चाहिए? So we are basically trying to eliminate location number 1 2 equals to 0. And what is your P? Usually the P value is identity matrix, correct? But now since we are trying to eliminate A12, which is this, तो यहाँ पर हम लोग क्या लिखेंगे? Minus sin theta, and if you exchange the rows and columns, so here you will write plus sin theta. Okay, and if you locate all the columns, that is 1 1 and 2 2, here you write cos theta, and here you write cos theta, correct? Okay, so now here I am just going to write down the expanded version of this. So this is P का transpose है ये. Okay, remember this is your P1. So I want to write the transpose of P. So here this will be cos of theta, and here it will be minus sin theta. I hope you understand the concept of transpose. Okay, and here this will be sin theta, and here this will be cos theta, multiplied by this is 3 6 6 and 8, multiplied by you have cos of theta minus sin of theta, and cos of theta. Okay, simple 2 by 2 matrix, right? So now let us quickly go through some of the calculations. Okay, so now I am multiplying these 2 matrices. Okay, so if I multiply these 2 matrices, I should get something like 3 cos of theta plus 6 sin of theta. Am I right? Then we have 6 cos of theta plus 8 sin of theta, and here this will be minus 3 sin theta plus 6 cos theta. This will be minus 6 sin of theta plus 8 cos of theta, and then again this will be multiplied with cos of theta minus sin of theta, and cos of theta. I hope this is correct. Okay, then again you go for expanded version of this. Okay, so let me write down So here what you should get, so this entire term will be multiplied with cos of theta. So this is going to become 3 times cos square theta plus 6 times sin theta and cos theta. Okay, then this entire term will be multiplied by sine of theta. So this is plus 6 times again sine theta cos theta plus 8 times sine square theta. Okay, so this is the first multiplication, right? Then secondly, now I'll go with this, okay, with minus sine theta. Okay, so this will be something like minus 3 times sine theta cos theta minus 6 times sine square theta. बराबर है? Then I have to go with the multiplication of this term with cos of theta. Correct? So this will be something like plus 6 times cos square theta plus 8 times sin theta cos theta. बराबर है? Then in the next cycle, I'll have to go with the multiplication of this with cos of theta. Okay, so let me write down. So this is minus 3 times sin theta cos theta plus 6 times cos square theta. Okay, so one part is done. Now the second part. So I'll be going with the product of this with sin theta. So this is minus 6 times sin square theta plus 8 times sin theta and cos of theta. Okay, now only the last part remaining, in which I'll be multiplying this particular with this, that is minus sin theta. So this is minus minus will go off. So this will be 3 times sin square theta minus 6 times sin theta cos theta. So one part is completed. Now the second part will come into picture, that is this with cos theta. So this is minus 6 times sin theta cos theta plus 8 times cos square theta. Okay, I hope I have not made any mistake. You want some time? We want some time. Ignite, please. So simple maths. Okay. Yes, meanwhile, please answer your attendance, okay? First shift students, okay? Roll number 3, 4, 5, 11 is online present.
Present, sir.
17,
Present, sir.
or 23, 24, 25 is 25 तो अपने लिस्ट में नहीं है, फिर भी ऑनलाइन आया हुआ है, क्या बात है? 45 is online present, 46, then 49 is online present, Then roll number 50, 54, 55 is online present. Roll number 61, then 62, 62 to hai nahi, 66, then 72, 79 is online present, 83, 84, and 86, I think online. Okay. Let me mark the attendance of second shift now. Yes, roll number 5, Janvi. Roll number 61, 62 is online present, 85 and 91. 85, okay, good. Okay, so I guess my calculations are matching with your calculation. Are there any discrepancies? Yes or no? Okay. So now everybody please pay attention. Okay. So now, if you observe carefully, why we are doing this? We are trying to eliminate location number 1 and 2. Okay. Since it is a symmetric matrix, 1 and 2 and 2 and 1 both will be automatically eliminated, isn't it? So here if you observe the equation which is there at location 1, 2 and 2, 1, they are same. Okay, they are same. Okay, so in this case what we are trying to do is a 1, 2, this should be 0. This means this particular element, this should be 0. But since it is a symmetric matrix, this will be also becoming the same. Okay, so for the timing, forget about that. So a12 has to be equated to 0. So your a12 is basically minus 3 times sine theta cos theta minus 6 times sine square theta plus 6 times cos square theta plus 8 times sine theta and cos theta. Okay, so now if you combine this sine theta and cos theta term which are over here, so this is going to give you minus 6 times sine square theta plus 6 times cos square theta plus 5 times sine theta and cos theta. This has to be equated to 0. Okay, so I think I missed theta over here. So now how we are going to solve this? There is only one equation and there is only one unknown, that is theta. Okay, so what I'm going to do is I'm going to divide this entire term by cos square theta. Okay, so if I divide this entire term by cos square theta, so this is going to become minus 6, and here what it will become? Tan square theta. Correct? Barabar hai? And this is going to become plus 6, and this is plus 5 times tan of theta. Barabar hai? Right? So basically this is an expression which is something like minus 6 tan square theta plus 5 times tan of theta plus 6. This is equals to 0. So this is very much similar to a x square plus bx plus c equals to 0. Barabar hai? So you already know the solution of this, that is x will be plus minus, sorry, b plus minus under root of b square minus 4ac divided by twice a. Correct? Now what is your x over here? X is nothing but your tan of theta. So sorry, minus b plus minus under root of b square minus 4ac, where your x is nothing but your tan of theta. And what is your b value? Your b value is basically 5. This is 5 A value is -6 and C value is 6. A value is -6. Okay. So now can anybody tell me what are the values of theta? This is going to give you tan of theta. Okay. तो तुमको थीटा की वैल्यू चाहिए मुझे. थीटा क्या आएगा? There are two values. 50. Okay, this is first value. Second value 33.6965. Whatever. Okay. So see, there are two values of theta which is satisfying this particular equation. So we can take any of the value, but most of the time you get a positive value. Okay. So if you substitute the value of theta in this particular expression, so this entire matrix, so ये जो तुम्हारा matrix है, this is your A matrix. Okay. Sorry, this is your A1 matrix. So now you know the value of theta. You just substitute the value of theta so that you can get the A1 matrix. करो अभी. Do it. Do it. तुम लोगों को सिर्फ तीन इक्वेशंस में थीटा डालना है बिकॉज A12 and 21 they are same. You should get this 12, 0, 0 and 1. Alright? तो जो बड़ा वाला मैट्रिक्स बना है ना, इसके अंदर थीटा सब्स्टिट्यूट करो बस. थीटा कौन सा सब्स्टिट्यूट करोगे? 56.30. You should get this. आएगा सेम आंसर आएगा because it is satisfying the equation, so there is no point. काही पॉइंट्स इकडे तिकडे होतील but answer will be same. Why I am asking you to take positive value so that every one will be on the same platform. That's why. You can take negative value also. Yes, anyone? 12, 0, 0 and -1. At least A क्या दो वाले? Sorry? 12 और -1 आएगा ही, और रादर 0, 0 तो 100% आएगा क्योंकि उसी से तो तुमने थीटा निकाला है ना. So 12 and -1 it should be the answers. Okay. Now please pay attention now. Everybody please pay attention. Yes, we have your attention please. So you see what we are trying to do in this method is we are trying to convert given matrix into a diagonal matrix. Since it was a symmetric matrix, since it was a 2x2 matrix, in just one step, it got automatically converted into a diagonal matrix. If it is a non-symmetric matrix, in that case, you have to go for one more triangle, in which you will be reducing this particular element. कौन सा वाला? ये वाला. But since it is already 0, further iterations or further steps are not at all required. Okay. So as a result of this, what will be your lambda values? This will be your lambda 1 and this will be your lambda 2. Okay. So in just one step your answer is done. Okay. Now, what about the eigenvectors? Eigenvectors, they are usually taken as a multiplication of P equals to P1 into P2 and so on. We have not calculated P2. It is not at all required. So in the 2x2 matrix, especially in this case, your P is nothing but your P1. Okay. And what is your P1? Your P1 is cos of theta minus sine theta, and cos theta. So can someone give me the values, please? 0. Sorry? 0.831. 0.554. Okay. So basically, you have now the value of lambda 1 as 12 और उसके जो vectors है, okay, eigenvectors, it is nothing but the first column, that is 0.554, 0.891. Okay. On similar lines, your lambda 2 is basically -1 और उसके जो vectors रहेंगे, that will be minus 0.831 and 0.554. क्लियर? सबको मेथड समझ में आई? कल और एक प्रॉब्लम लेना है कि छोड़ना है? लेना है तो ठीक है, कल टाइम पे आ जाना और एक क्लास ले. फ्रॉम माय साइड सिलेबस इज नाउ कंप्लीट. ठीक है, सो वी विल टेक वन मोर प्रॉब्लम and we will take only 2 by 2. ठीक है, because 3 by 3 out of question. ठीक है, okay. So I have already taken your attendance, so you may leave now. We will meet tomorrow once again.